Hello dear friends, welcome my channels. Today's discussions is Markov stochastic process. Stochastic process, it is a family of random variable xt where t belongs to family of random variable xt where t belongs to capital T, where t belongs to capital T, defined on a common sample space S and indexed by the parameter t, and t belongs to capital T, and the value of xt is called states, and the set of all possible values of xt from state space of the process is denoted by I. The set of all possible values of xt, the set of all possible values of xt is called state space of the process and is denoted by I. The state space is discrete. Then stochastic process is known as a chain. The state space is discrete. Then the stochastic process is called the stochastic process is called the state space is discrete. The stochastic process is called chain. In this case, state space is assumed 0 to 0. State space is assumed 0, 1, 2, 3 up to this. This is called state space. A finite stochastic process consists of a sequence of experiments in which each experiment has a finite number of outcomes with given probabilities. So friends, what is Markov process? A Markov process is a stochastic process whose entire past history is summarized in the current state. The future is independent of its past. So friends, now I want to discuss Markov process. Markov process is memoryless process. A Markov is memoryless process is a stochastic process. Must remember, it is stochastic process whose entire past history is summarized in its current state. Entire past history is summarized in current state and future is independent with past. And Markov chain is a Markov process in which the state space I is discrete, finite or countably infinite. Thus, a finite Markov chain is a finite stochastic process consisting of a sequence of trails whose outcomes, say x1, x2, x3, satisfy the following two condition. Each outcome belongs to the space I, which is finite outcome, and the outcomes of any trial depends at most upon the outcome immediate preceding trials and not upon the previous outcomes. That is, it is very simple word. P xn equals to in, and x0 equals to I0, x0 equals to I0, and x1 equal to I1, x2 equals to I2, x n minus 1 equals to I n minus 1. That is P xn equals to in divided by xn minus 1 equals to I n minus 1. Important note that discrete state space, continuous state space. So state space are two type. One is discrete, another is continuous. Discrete and another is continuous state space. Let xn equals to k, xn minus 1 equals to j, xn minus 2 is equal to j1, xn minus 3 is equal to j2, x1 is equal to jn minus 1. So friends, we will take whatever we will take last term and second last term. Means last term is xn and second last term is xn minus 1. So we take this and another these portions will be removed. So we can write pjk is equal to xn equals to k, xn minus 1 equals to j. This is my transitions probability of Markov chain. Now we will discuss the probability P12. P12 is equal to PR is equal to x3. PR is equal to x3 equals to 2 and x2 equals to 1. So friends, whatever you see that x1 and x2 is the not, this is cut because this is the first last is x3 and second last is x2 minus 1. So I take this and this is my P12, and this type of Markov chain is the first step my Markov chain. This is first step Markov chain. This is first step Markov chain. Another is Markov chain is two kind, homogeneous Markov chain and non-homogeneous Markov chains. Markov chains is two kind. One is homogeneous Markov chains. Another is non-homogeneous Markov chain. PJK is dependent in and non-homogeneous and independent from n and is homogeneous. When xn is dependent on n, pjk is dependent on n, then it is non-homogeneous, and independent from n, this is homogeneous. One step transitions probability. One stage transition probability of xn plus 1 equals to k and xn equals to k. This is pgk. And two step, this is very important friends, one step transition probability and two steps transition probability. PRxn plus 1 equals to k and xn equals to j is equal to p2jk. And three steps, when step is 3, then I write 3. When 2, this is 2, and 1 we will not write. And m step, this is the m step probability. This is m step probability, m minus 1. And transition matrix or matrix transitions probability is PR is equal to xn greater than xn and n greater than equals to 1, and where PR xn equals to k, xn minus 1 equals to j is equal to pjk, where j and k is state, and p is equal to p11, p12, p1n, pn1, pn2, pnn is a single stochastic process. And when 1 and pij greater than equals to 0 and pjk equals to 1 for all j, so for single stochastic case, single stochastic process. How? Because when I add these two, then it is 1 in row, then it is single. But when it is the adding, means I will write in here, it is better, that p11, p12 up to the p1n, and p21, p22, p2n. Pn1 and Pn2, Pnn. Then it is then P11, this portion, summation of this portion means P11 plus P12 plus P1n equals to 1, P21 plus P22 plus P2n equals to 1. This is the all the summation positions, friends. All the sum is sum of the probability is 1. Then it is single, but when it is double, then it is also, you say Pij greater than equals to 0 and Pkjk is equal to 1, and Pjk is equal to 1 means j is in here, where k for all k means in here P11 plus P21 plus Pn1 equals to 1, where column is fixed and row is variable. Variable. Similarly, where row is fixed but column is variable, this kind of summation is 1. Summation part is 1. So this is the double stochastic process. This process is double stochastic process because we get P11, P21, Pn1 equals to 1. Similarly, we get P11 plus P12 plus P1n equals to 1. So I get total 2. Similarly, another portion you can get everywhere. It is double stochastics. For example, now I am coming to discuss example. The given matrix is half and half. This type of matrix is, this is 1. This is 1 means half plus half equals to 1 and 0 plus 1 equals to 1. So this matrix is single stochastic matrix, and this matrix is half plus half equals to 1, half plus half equals to 1, and half plus half equals to 1. And this stochastic you can see in this way. When you add this, then you get 1. When you add this, you get 1, and when you add this is 1. So this matrix is double stochastics, friends. This is double stochastic process. Now we discuss that Prxn, k and xn minus 1 equals to j equal to Pjk transitions probability. Transitions probability is equal to Pjk. And now if we get xn plus 1 equals to k and divided by x. So friends, whatever you see that this is this kind of matrix, this kind of probability equals to Pjk. This is the this kind of probability, must remember. So example, probability PR x3 equals to 1 and x2 equals to 2, that this equals to probability x3 equals to 1 divided by x2 equals to 2 and multiply with probability x2 equals to 2. So friends, how can we get? Because we know conditional probability PA by B equals to PAB divided by PB. PA divided by B equals to PB, and PAB P AB equals to probability PR equals to x3 equals to 1 comma x2 equals to 2. This is the probability AB. So friends, so whatever you see that I can write this way, and after that I can write P x3 and 1. So how can I write? This is this way. It is this way. Chain is this way. So it is P21. P21. So I can write P21 into probability x2 equals to 2. This way I can write. Another way is probability x3 equals to 1, x2 equals to 2, and x1 equals to 2, and x4 equals to 4, x0 equals to 4. This way I can write, and now it is going this way to this way, this way to this way, and this way to this way it is going. So how can I write? It can be written this way: PR probability of x3 equals to 1, x2 equals to 2, x1 equals to 2 divided by x0 equals to 4. It can be written, and PR x0 equals to 4. So friends, it can be written this way, that this is the going this way, it is going this way, means P21 and multiply with P42 multiply with P22 multiply with P42 P22, and another is PR x0 equals to 4. It can be written. Another example is, if I choose PR x4 equals to 1, x3 equals to 2, and x2 equals to 4. This way it can be written x0 equals to 2, and after that it can be written you can see friends this way 2 to 4 and 4 to 2 and 2 to 1. So my multiply is P21 cross P42 cross P24. This is the probability multiply and also probability is PR is equal to x0 equals to 2. This way it can be written. Next is transitions matrix. Transitions matrix. Now I want to discuss transitions matrix. Transition matrix and is P is equal to 1 by 2, 0, 1 by 3, 1 by 4 and 1 by 4, 1 by 4, 1 by 4, 1 by 4 and 2 by 3, 1 by 3, 0, 0 and 0, 0, 0, 0, 1. Friends, why Markov chain is important? Because 1, 2 and 3 marks will come from this in CSI net examinations. CSI net examinations for mathematics students, they can get 2 and 3. 3 marks is coming. 3 marks is coming this from this question, and this is very easily we can get these marks, and 3 marks is very important for CSI and net gate. So that's why I am talking about Markov chain. This is a 1, 2, 3, 4. 1, 2, 3, 4. And now my state space is, what is my state space? My state space is 1, 2, 3, 4. This is my state space. And I can write P x4 4 equals to 2, x1 equals to 1, x2 equals to 2 and x1 equals to 2. This I can write this way. P probability value, and this value can be written. P. This question my asking question is this. This is my asking, that how can I find out these portions. So you will see that you will multiply this way, 2, 2, 2. So what about this question? Another factor, that it is given that PR of xi equals to I equals to half. So this kind of questions, how can I solve? This is the very simple. First is P. This is the way, direction is according to the direction. So first is P 1 to 2, and another is P 2 1, another is P 2 2, and question is asking PR x1 equals to 2. And this value, you will see that P1 2, P1, this is 1 and this is 2, this value is 0. P1 2 is equal to 0. So my first value is 0. First answer is 0. Another is P21. What is my P21? This is my 2 and 2 1. This value is my 1 by 4. 1 by 4 is this value. Another value is P22. P22 value is also 1 by 4. So I am just putting the value 1 by 4 into 1 by 4 into half. So this value is 0. So we can get easily this type of probability, friends. This is asking in CSI net gate. This type of questions is asking CSI net. Another question is PR probability x4 equals to 2, x3 equals to 2, and x2 equals to 1. How can I find out, friends? This is also simple, easy. This way, first is this is this way. So I get this value p22 into p21 into pr is equal to x2 equals to 1, and it is also given pr x2 1, the value of pr x2 equals to 1 by 3. This is given. So whatever I get by the transition matrix 1 by 4 into 0 into 1 by 3. How I get 1 by 4? P22 is equal to, you see, 1 by 4, and another factor, you see, P21 is equal to 0. P21, so it is not P21, I am writing wrong, it is 1 2, because 1 to 2, I also mentioned this is this way. You will see that my diagram, this 1 to 2, so this way, this is my arrow, so my chain is going to 1 to 2, so it is 0. So this is that's why this value is 0. Now from the another problem, another example, that pr x4 equals to 1, x3 equals to 2, and x2 is equal to 1. So how can I write this, friends? And if there is this way, it's conditional probability, x2 1 equals to 0 given, so it can be written this way, multiplying, and there is no, I don't need another value x2 equals to 1 to know, so it can be written p2 1, because it is going to 1, another is p1 to 2. Okay, so this value is 1 by 4 into 0 equals to 0. So this value is coming 0. Next problem, friends. Next discussion is directed graph. Directed graph. Directed graph is very, very interesting. Directed graph is very, very interesting. So friends, how can I draw a directed graph, and how? From the matrix, from directed graph, transitional graph. Directed graph is called transitional graph of Markov chain. If the matrix is given P is equal to, it is better with example, P is equal to, suppose 3 by 4, 1 by 4, and 0, and 1 by 4, 1 by 2, 1 by 4, and 0, and 3 by 4 into 1 by 4. So friends, I have to check it is stochastic and it is Markov, how it is transitional matrix or not. At first I adding these portions, then we get 1, and I add this all, then I get 1, and I add this all, then I get 1. So whatever you see that my adding positions, I get everything is 1. Now how can I draw this? So it is Markov chain. Now I draw graph. My transitions, my state space is 1 2 3 1 2 3. So I write this is 1, this is 2, this is 3. This is my 2 state space. So now you will see that 1 2 1. We see that 1 to 1 it is not 0, so it is there. This is 3 by 4. This portion is 3 by 4, and after that we see that it is going to 1 to 2, so it is 1 by 4, and it is 1 to 2. My journey. Another journey is 1 to 3. If we see that my another journey 1 to 3, that is 0, so no graph, means no path I get in here. Again my next journey 2. When I go to the 1, then whatever I get another path, then I can get easily by 1 by 4. And when I go 2, then my journey is 2 to 2, then my self I go to 2 from 2, so this probability is half. And after that I go to the 3, then I shall go to 3, so my journey is this direction is 1 by 4. And after that I count the 3 to 0. When I go to 1, then my is 0, my path is 0. After that my path is 3 by 4, so I will go to the 2. This path is 3 by 4, and another path is I have to go 3 to 3 this way. That is this path is 1 by 4, and this is my directed graph. This graph is called directed graph. Now again I will give another example that how can I another example of the directed graph, because this is very important. Directed graph, if you know how to create directed graph, you can easily find out the probabilities. That's why I teach how to create directed graph from transition matrix. My matrix is another matrix is P, and 0 2/3, 1/3, 1.5, 0, 1 by 2, 1 by 2, 1 by 2, and 0. This is my transition probability. And my directed graph, my state space is 0 1 and 2, 0 1 and 2, and 0 2, 0 2 1, this is 1 0, another is 2. So now friends, I start to draw a graph. How to draw the transition graph? 0 to 0, so 0, no path itself. 0 to 1, then when it is multiplies, then it is 2 by 3. So this way I can go 0 to 1, then my probability is 2 by 3. and 0 to 2 my probability 0 to 2 my probability is 1 by 3. Must remember, friends. And after that 1 to 0, when I go 1 to 0, then 1 to 0, then I get probability half. And when I go 1 to 1, then my probability is 0. So 1 to 1, no self path. When it is go 1 to 2, then it is half. 1 to 2, then it is half. And when it is go 2 to 0, then it is half. And when it is 2 to 1, this value is half. 2 to 1 and 2 into no self. So this is my directed graph, friends. I hope that it is clear for everyone, because I give 2 examples how to draw a directed graph. Next problem is higher under transitions. My discussion is higher under transition. So friends, we know that one step Markov chain. MC we know one step, but when it is two step, means PJK2. When it is probability of xn plus 2 is equal to k, and divided by xn equals to j equals to pjk comma 2. And when probability, this is the higher order, higher transition. So probability xn plus m, this is the mth step, is equal to k, and divided by x n equals to j, then it is p m minus 1 jk. So friends, our probability should be p square is equal to p dot p, and p cube is equal to p square dot p. This is, and p to the power m plus n is equal to p to the power m and p to the power n. This is the probability. So friends, now we will ask some question, then we will go to discuss some questions, then we can ask how can I find out the two path and two higher transitions. So p is equal to, this is my matrix, p is equal to 3 by 4, 1 by 4, comma 0, and 1 by 4, 1 by 2, and 1 by 4, 0, 3 by 4, and 1 by 4. This is my p. And now I have to find out P0, 1, 2, and where PR equal to xn plus 2 equals to 1 and divided by xn equals to 0, and I have to find out P112 equals to PR xn plus 2 equals to 1 and xn equals to 1. I have to find out. So friends, how can I find out this kind of probability? Because this is the probability multiplication of 2. So friends, it can be find out in the two ways. There is the two method. They are asking, this is the how value is what. So two methods. First is multiplying matrices another is, second is from directed graph. How can I find out? This is my two way. So friends, my probability is, my matrix is P. So it is I have to find out P112. So how can I find out? At first I multiply P into P. Then whatever I get, 3 by 4, 1 by 4, 0, 1 by 4, 1 by 2, 1 by 4, and 0, 1 by 4, 1 by 4. And after that multiply, I same matrix I multiply 3 by 4, 1 by 4, 0, and 1 by 4, 1 by 2, 1 by 4, 0, 1 by 4, 1 by 4. So whatever I get P square is equal to 5 by 8, 5 by 16, 1 by 16, and 5 by 16, 1 by 2, 3 by 16, 3 by 16, 4 by 16, and 1 by 4. This is my P square, friends. So how can I get? I get P square 0, 1 is equal to 5 by 16, friends. You will see this is 0, 1, 2, 0, 1, and 2. And P01, this is my 5 by 16, friends. I hope I can clear. And similarly, so this value is divided by, this is the 0, 1, this is my, they ask, so they asking P01, this is 5 by 16, and this is P112, this value is equivalent to, when it is multiply, you will see this value is P11, this value is 1 by 2, so this is 1 by equals to 1 by 2. This is my total value. So friends, I hope I can clear that how can I find out this is. And another way is directed graph, friends. How can I draw directed graph? What is my directed graph? Again, you have to see the 3 by 4, 1 by 4. So you will see that 0 to 0 I write at first. This is 0, this is 1, and this is 2. Let's check that 0 to 0 is also given. So I get a path. That path is 3 by 4. You can see, and after that 0 to 1 I get 0 to 1. You will write in here. I have to write in here 0 0 1 2 0 1 2. So 0 to 0 that I get, 0 to 1 I get 1 by 4. So I write 0 to 1 equals to 1 by 4. And after that 0 to 2 no path because 0. And after that I can get 1 to 0 is 1 by 4. So my another path is 1 to 0 is 1 by 4. Next friends, 1 to 2. 1 to 1 to 2 is 1 by 4. 1 by 4, and 2 to 1 my 2 to 1 is and this value is 1 by 4. So you will see that 2 to 2 to 1 is 3 by 4, and 2 to this 1 by 4. So I draw the complete graph. I hope no error in here. So my path is, so friends, my path is 2. How can I approach in 2 path in 1? So at first I write P00 P00 2. So friends, how can I go P00 from 2? So first is 00 is path, my only one path. My only this path, this way I can go, and again I can go this way 0 to 0. So it is P00 into P00. Again I can come. And another way is 0 to 1 I can go 0 to 1 and 1 to 0. This is my 2 way. So it is adding is P01 into P10. So this is 3 by 4 into 3 by 4 plus 1 by 4 into 1 by 4. This way can be written, and it can be right 5 by 16. So you will check my answer is also 5/16 p. Sorry, it is 5/9/16 plus 10/16. So this value is not 5/16. This value is 5/8. This value is 5/8. You can check in here that you get it is P00 is 5/8. So easily get it from directed graph. Another is P0112 P012 can be written P00 into P01 this way, and another is P00 01 into P11. P11. We'll see that P11. Okay, it is the graph is, my graph is incomplete. There is also 1 This is half. This position is half. P11. My graph is incomplete. P11 is half. Because P11 you can see. So whatever you get, P00 value is 4/9/16. I can write 9 this is 3/16 plus 1/8. That means 5/16 is the value. So friends, you get this value is here 5/16. So I don't need to multiply matrix multiplications. I can easily find out with the help of directed graph. Next question is coming December 2017 CSIR net December 2017. That is xn and n greater than equals to 0. This is the Markov, and transitions set is 1 2 3, and my matrix is P equals to 0 half half and half 0 half 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 0. So friends, how can I get this value? Px3, I have to find out Px3 equals to 1 divided by x0 equals to 1. Then I have to find out this value is P113. This probability I have to find out from this matrix. So how can I get, friends? This process is the very simple. I have to multiply like P into P to thrice multiply, but I don't need to multiply if I solve it with the help of graph, directed graph. So let's start to draw a graph. This is 1, this is 2, and this is 3. So now I write in here 1 2 3 1 2 3. So now first is 1 2 3 1 2 2 1 2 2, 1 2 2, this is half. This value is half, and another is 1 2 to 3, this value is half, and 2 to 1, that is half, and 2 to 2, no, another value 2 to 3, this is half, and 3 to 1, this is this is half, and 3 to 2, this is half, and 3 to 3, no particular value. So friends, this is the main property, this is the main directed, I have drawn directed graph. Now I have to find out P113. So friends, how can I go 1 to 1? So only one possible, 1 to 2. This is the possibility is P1 to 2 into P23 into P31. Then it is going to, again you see that 1 to 2, P1 to 2, and P2 to 3, 3, and P3 to 1. Then one way. Another way is I have to draw, that is P1 to 3. I can go P1 to 3 this way, P1 to 3 into P3 to P3 to 3 to into P to 1. Means I can easily find out this value. So P1 to P1 2, this is half, P23, this is half, and P31, this is also half, plus P13 half, P32 half, and P21 half. That value is 1 by 4. So this is my value, P311. Now friends, we start to discuss communication relation. Communication relation. This is very, very important, friends. What is communication relation? First is that accessibility. My discussions is accessibility. State J is said to be accessible from state I, said to be accessible from state I, and if Pij n greater than 0 for some n, then I communicate with j. Means if Pij n equals to 0 for all n, then I tends to j, means I does not communicate with j. So friends, let's start to give some example for clear this question, this paper. So example is xn comma n greater than equals to 1 and s equals to 1, 2 and 3. So friends, my P is, I choose a P, my transition matrix P is equal to half, 0, half, 0, half, 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 0. So this is the Markov chain, and if you see that I tends to j, I communicate j and j communicate k. In here 1 communicate 2 because 1, 2, 3, 1, 2, 3, 1 communicate 2, 2, P12 equals to P12 is equal to 0, but P122 equals to 1 by 4 greater than 0. So in case of P square I1 communicate to Pij n greater than 0 and Pjkn greater than 0 for some n, that implies Pjkn greater than 0 for some n, means it is transitivity hold, friends. Some n means transitivity holds in the communicating systems. So friends, example again, I am going to give one example. P equals to 3 by 4 0 1 by 4 and 0 1 by 2 1 by 2 1 by 3 1 by 3 1 by 3, then my state space is 1 1 2 3 1 2 3, then 1 communicate to P12 P12 is equal to 3 by 4, means 1 communicate 2 and 2 communicate 3, so it is P23 is equal to half, which is greater than 0, so P13 equals to 1 by 3 greater than 0. So this is the possibility. So this is the example of the symmetric. Now I transitivity. Now I discuss symmetric communicating state. Symmetry communicating state. Two state I and J is said to be symmetric communicating if I tends to J and J tends to I, that implies I are the symmetry communicating state. This is the communicating state I, communicating state with J. Now friends, I give one example. For example, P equals to 1/3, 1/3, 1/3 and 0, 1 by 2, 1 by 2, 1 by 4, 3 by 4 and 0. So friends, it is state space is 1, 2, 3, 1, 2, 3. So 1 to 2, you will see 1 to 2, P12 equals to 1 by 3 greater than 0, and 2 to 1, that is P21, 2 to 1 is equal to 0, so this is not possible.